We'll start off this lecture by looking at the force acting on a current carrying conductor. So take a look at this diagram. You have a copper rod placed in a region of magnetic field. So when the circuit is switched on, there will be a current flowing through the copper rod. Now what happens is that a current flowing in a copper rod has a magnetic field around it. This magnetic field, due to the current, will interact with the magnetic field due to the permanent magnet. Now what happens is that in this case, the copper rod will be made to move in one direction. So what does this show? It shows that in the presence of a magnetic field, a current carrying conductor will experience a force. Now, how do we determine the direction of this force? To determine the direction of this force, we will look at the Fleming's left-hand rule. So this diagram here presented to you is the Fleming's left-hand rule. So using your left hand, your three fingers, the thumb represents the force. So I label it as F. The index finger represents the magnetic field, which is B. Now this magnetic field, it refers to the external magnetic field, not due to that of the current, but due to that of the external magnetic field, maybe by placing a permanent magnet near to the conductor. Current, represented by the middle finger, is the letter I. So for easy recall, we can take a look at Fleming's left-hand rule as FBI. How do we use the Fleming's left-hand rule? Let's take a look at example 1. So in this case, I have the conductor, let's say this PQ, this rod, placed in a region of magnetic field. The north is on the right, the south is to the left. So the direction of this magnetic field is going from right to left. And you look at this battery. So in this case, the current is going down, and to the other side, the current is going up. So use your Fleming's left-hand rule, FBI. B is pointing from right to left. I is going towards P. What is the direction of the force? The force is obviously acting upwards. So as a result, the answer is A. Let us take a look at example 2. So which diagram shows a correct direction in which the wire will move when placed in a magnetic field? Now first of all, the magnetic field has series of arrows pointing from right to left. Now this shows that the right hand side, the field is north, and towards the other side, the field is south. So this is where your index finger will point using your Fleming's left-hand rule. Now let's consider option A. Now for option A, you see a circle with a dot in the middle. Now this simply means that the current is pointing out of the page towards you. So if you use a Fleming's left-hand rule, FBI, your B is pointing from right to left, your I is pointing upwards. Look, what happened is that the force is going down, not up. So option A is out. How about option B? Now in this case, you realize that option B is also out of the answer. The reason is because we cannot have the direction of the conductor moving in the same line with that of the magnetic field. They both have to be perpendicular to each other, remember? So option B is also out. And that left us with two other options. Take a look at option C. Now you see there's a cross in the middle. Now when you see a cross, this simply means that the current in this conductor is moving into the page. So when you use your FBI, your I, which is represented by your middle finger, should place into the page. Alright, pointing into the page. So FBI, your B is pointing towards the left, your I is pointing into the page, and what you see is that your thumb should actually be pointing upwards. So this should be where the force is. So obviously C is also not the answer. So as a result, you'll realize that D is the correct answer. So if you use an FBI, you'll notice that the force is indeed pointing in the downward direction. So using Fleming's left-hand rule, the answer is D. Thank you for your attention. This is the end of the lecture video on Fleming's left-hand rule.